example 3, the graph of 1 over x. So now here, because of the activity we did at the beginning, you see that equation, and right away, your brain should get a picture of that graph. So what's important on my 1 over x graph? An asymptote at x equals 0, an asymptote at y equals 0. It has this shape, and the key points are 1, 1, and -1, -1. Okay? So we see something we've done already, the graph of 1 over x. Boom, that picture comes into our mind. It's been translated 3 to the left and 2 units up. What is the equation of the image graph? So if you moved it 3 to the left and 2 units up, how would you write that equation? Well, it's a 1 over x graph, so we'll have 1 over, but instead of just having an x on the bottom, how would we show that 3 units to the left? That would have an x plus 3 where the x was, because that's inside the function. How do we show the 2 units up? That would be plus 2 afterwards. Okay? Now, I think that the reciprocal graph is the hardest one to put things inside and outside the function, just because that x is on the bottom. I don't know why, but it seems to be the hardest one. Okay? I want to talk about function, well, that's an ugly C. I want to talk about function notation here and how you can use function notation to help you with regular notation. So our regular notation here, we had y equals 1 over x, and we translated it 3 units left and 2 units up. If this question had started off in function notation and said you had the function y equals f of x, and you wanted to translate it 3 units left and 2 units up, how would that look in terms of f? So if we're in function notation, we would need to write our answer in terms of f, because that's all we have. Would you agree that your new equation, you would show the 3 units to the left as x plus 3 inside the function, and then the plus 2 after the function? Is that good in function notation? Yes. The f symbolizes any function. But now, if you're having trouble writing the actual equation because it's 1 over x and that's difficult for you, you can also use function notation and how functions work to write this equation. So, in my next little line here, I'm going to say if f of x, if the function, any function, was 1 over x, how do I write y equals f of x plus 3 plus 2? So if my function was 1 over x and I wanted to show 3 to the left and 2 up, how do I show that? How do functions work? Would you agree that if I asked you f of 2 and f of x was 1 over x, you would write 1 over 2? People or students seem to have the easiest time if they're numbers. If I said f of 3, you'd say 1 over 3. Right? Would that be no problem? Okay? And what you're noticing, or what you're doing here, is you're noticing that whatever x is, you just change where the x is with whatever numbers. So when I had 2, I changed it with 2. For whatever reason, my highlighter is really slow. Yeah, it's like frustratingly slow. Maybe it'll pop up all of a sudden, maybe not. But that means everything is not working. Oh, there we go. Highlighter, highlighter, sad face. That means here, if I'm trying to do f of x plus 3, whatever I put into my function replaces where the x was. So I'm going to rewrite this. This is really important for understanding function notation. Instead of writing 1 over x, can you see that f of x plus 3 would be 1 over, I replace the x with x plus 3. That's what the notation means. And then I have a plus 2 afterwards. Well, I would still have a plus 2 afterwards because this part is that. Does that make sense? That all a function does, whatever you put in, it replaces every x with what you put in. So if you put in a 2, it replaced the x with 2. If you put in an x plus 3, it would replace the x with x plus 3. Sometimes it's going to be easier to write the translations in function notation and then write it in the actual notation. Would you like should I show an example where I think it would be harder to do it directly and easier to do it with function notation? Okay. Okay. Here's an extra example. If y equaled a parabola x minus 2 squared plus 3, and it was translated five right and 2 up, comma, what is the equation? Okay. In function notation, 5 right would be x minus 5, 2 up would be plus 2. That's function notation. That would be straightforward inside the function, okay? Minus 5, outside the function, plus 2. If I let my function equal what I started with, and maybe some of you are really good, you could go directly from this and say 5 to the right, 2 up, it would be at x minus 7 squared plus 5. Maybe you could see that. But if you were trying to do this notation, using function notation might be easier. What does this mean? This means I take my function, and wherever I have an x, I replace it with x minus 5. So what would that look like? That would look like, there's my x. I'm going to replace it with x minus 5. Then I have a minus 2 squared plus 3. This is this. Can you see that all that's happened is the x got replaced with x minus 5? That's what a function does. And then what did I have afterwards? I still had plus 2. Now if I simplify this, can you see that you would have x minus 7 in the brackets and plus 5? So here I used function notation to help me get my equation. Okay? But the thing about math is I want you to be able to think all sorts of strategies to help you. In this one, I actually think, I might use my knowledge of graphing. That's a parabola. Its vertex is at 2, 3. Opening up. If I moved it 5 to the right and 2 up, does it make sense that my vertex that was at 2, 3 would shift to 7, 5? And then if I knew that, does that equation come out really easily? Okay? And now that I show you the graphing one, you're like, ooh, I like that one the best. But that's the thing. Sometimes the equation can just be done easily without having to do anything. I think this last example that we did, right? Starting with 1 over x, just adding 3 there, adding 2, I would do that directly. I didn't think about the graph. I didn't redraw everything and get my new equation. Okay? Sometimes the function notation might be the easiest way to do it. So you want to have that ability to think in functions. And sometimes thinking about it graphically becomes the easiest way to do it. And so what we want to be able to do is when we get a question sort of like, okay, what does it look as a graph? What does it look like in algebra? What does it look like as a function? Which way do I want to try to solve it? And if I try it one way and it's not working, maybe I take a step back and say, okay, I'm going to wait for a bit. I'm going to try looking at the graph now. Maybe that helps me more. Okay? So when we're solving a problem that we're not quite sure how to do it, there are more than one way to think about it. And seeing this can be helpful. Okay, questions 12 to 15.